And welcome to this video. I would like to go over how to make a cylinder head, if not exactly like this, very close to this in SolidWorks. This is a relatively high level of detail. You have 4 valves per cylinder with valve seats and spark plugs and things cut out. You have coolant input and a coolant output, oil input and oil return. You have, of course, your intake and exhaust channels. You have your spring perches and your valve train uh, and your valve guides and things like that. You have your oil supply, oil return, coolant channels. You even have some places to put freeze plugs. So this is a relatively higher level of detail. You have even the groove that you would put a gasket into for the valve cover bolt holes, the cylinder head bolt holes, the studs. So hopefully this is a decent example of making something relatively complex in SolidWorks. Like anything else, it is a bunch of simple things put together to become something complex. This, of course, is conceptual reference only. So why don't we get started? I am going to start by opening a new part. And on the front plane, we can start a sketch with a center rectangle, and I'll make this 5 inches wide, and we'll go 3.5 inches tall. And then I can extrude this to a distance of 15.25 inches, but I'll do that mid-plane. Now that I have that, I can begin, I'll even make a reference plane, and we'll go 0.3 inches. We'll flip the offset to go into the cylinder head, and we'll call that our spark plug reference plane. That'll reference the height of our spark plug in the combustion chamber. But I'll sketch on this bottom face, and I'll begin by sketching 4 circles after I get normal to my sketch. These 4 circles, of course, will be reference places for our cylinders. I'll highlight all 4 and make them for construction, and we'll do 3 center lines to run in between them, except I want my center lines to snap to the cylinders and not to the origin. So to center on the origin, I'll simply select midpoint and be coincident to the origin. We'll make these center lines of equal length as well as these 4 cylinders, and we'll go something like 3.5 inches on spacing. We'll give our cylinders a diameter of 3.25, which is probably decently appropriate. That gives us enough wall to work with if we need it. Now that I'm fully defined, I'm going to make a valve reference place. So we'll go here, and we'll say that this valve from the center of the cylinder, the center lies 0.6 inches away horizontally and also vertically 0.6 inches, and I'll give this a diameter of 1 inch, and we're fully defined. Now this valve, we're going to be using a loft, probably a loft involving 4 lines. And sometimes it's easier to loft using the same number of elements, right? 4 lines into 4 lines, and so instead of making 1 arc, I'm going to make a center point arc, and we're going to make 4 different arcs to make that loft a little more smooth. We'll set these to be vertical. I'll run 2 center lines, and we'll give these a parallel or perpendicular rather relation, and I'll use a tangent arc. There we go. And we'll just fill this in with 3 tangent arcs. Then we can fully constrain this with 2 more relations, horizontal and vertical. Great, so now that we're fully constrained here, I'm going to rebuild, select this face, and sketch, and we'll put a center rectangle on there. And I'll grab this center and the center of my other sketch and make it vertical to place it vertically. Now if I can get back normal, there we go, I will make this 1 inch wide, and we'll go with something like 1.5 inches long, and then from, I'll say, the center to the bottom of the cylinder head is going to be 2 inches, and we're fully defined over here. So let's get started with some lofting paths. I want to start by 3D sketching Actually, before I do that, I think I'm going to highlight this plane and sketch on it. So highlight that spark plug plane, and we'll create a sketch, and we'll convert entities. And I'm going to convert the entities I've sketched down here up to this next plane. And that should help make it easier to choose some sweep paths. So I'm going to exit the sketch, rebuild, and I'm going to go into a 3D sketch and run a line from here to here and do a third line. And then back here, I don't want any automatic constraints except for coincident on this line because I want to make it parallel to the top of my plane, and that way I can really only twist around and pivot around that point like this, but stay on a flat plane. I'll use a tangent arc, and I can add the tangent relation in to these 2 points, and now all that's left is either a radius or a distance. And what I'm thinking is this plane marks the top of the spark plug, which means that this line right here, or this empty sketch, this inactive sketch rather, that I'm highlighting with my mouse, marks right where the valve is probably going to start. There's going to be some curvature, but this is a rough estimation. And I still have to, after this point, cut in a valve seat. And so I need some extra straight space after that. So I'm going to give this a dimension of 0.2 inches, which gives me about 10,000ths of an inch here. And what this ensures is this guarantees that this will remain circular at least until 0.2 inches past where the spark plug plane is. That's important because if I start curving immediately after this, whatever I cut in isn't going to be completely circular for my valve seat, and that could spell disaster later on. Of course, we're trying to make things with as much design intent as possible, so even if we make a mistake, it should be easy to correct it without any consequences. But you never know for the future, so let's plan ahead by making sure that we cut in with a very straight line. I'm going to do the same over here. Do another line. We'll make it parallel to the top of our cylinder head, and adding in a tangent arc. We'll add in a tangent relation over here as well. And now, but I'm in an active sketch, so ignore everything I've just said, and now I'm going to create a new 3D sketch. And we'll add in that parallel relation. Now I'll throw in a tangent arc as before, and will be tangent. For design intent, I'm going to take the line that I've already sketched and this line and make them equal. And that will be a good sweep path. I want to do this on the other side as well, so we'll start a 3D sketch with our line in the same method as we have done before. We'll grab this bottom point and of course make it parallel to the top of our cylinder head. And again, with our tangent arc, we can add in a tangent relation. And again, we'll make this equal, and that will guarantee that we'll have enough room to cut in that valve seat. Now again, we'll choose a 3D sketch, and over here we'll add in another line, make it parallel to the top, and add in our tangent arc. Tangent. And we'll make these of equal length. So now if I update one dimension, every path updates. That's kind of the beauty of design intent. So let's work out our subtractive loft. I'm going to go to loft and cut here, and I'll choose this profile to this profile to this profile, and I can choose all 4 of my guide curves, and you can see it every single time getting more and more accurately shaped until we come to this final piece. And there is our cut. Perhaps I can make this a little bit more exciting looking now that I have something to look at by changing my appearances, and I can go to metal, steel. I really like in this application the way that cast stainless looks. I might not want to make the material cast stainless, but it's a nice appearance. So now that I have that cut out, I might as well mirror this, and I certainly can linear pattern it as well. But it might be handy to have a plane that references the center of my cylinder. So I'm going to show my sketch, but that's the wrong sketch. I'll show my lofted cut sketch here, and I'll choose a plane that is parallel and coincident on this point. And that would be the center point of my cylinder. And so now I can mirror, and it should be easy to mirror this by feature because there's only one feature that we're mirroring. And again, that way, no matter what I do, these will always stay centered over my cylinder, whereas if I modify my cylinder placement, a linear pattern may not update the way that I want to. Okay, with that being done, let's reference my spark plug plane. And this is a really fantastic time because I just think it's kind of fun to make this loft. I will highlight my spark plug plane and sketch, and I'll get normal with Control 8, of course. And I'll make a circle, and it looks like I actually need to show this sketch once more. Oh, it looks like I'm already showing it. So I'll grab the center point of my cylinder from this inactive sketch and make this circle coincident. And then from here, I can give it a dimension, and I would prefer 1.75 at least for now. I would also like to highlight this face. First I have to exit sketch, highlight this face, and sketch on this plane. And I can make another circle, highlight my inactive sketch, and make sure that these are equal. And that way, any updates I make, again, will be reflected in here with as few dimensions as possible. I'm going to do a few things. The first one is hide this sketch, because if I have a line over a line, it's very possible I can grab the wrong sketch by accident and have it throw me off. And what I'll do is, again, another subtractive loft. But not a cut, rather, but a loft. And we'll go from here to here. And in my end constraints, I'll be normal to profile to give me sort of that cylinder head profile. And there I've cut in my cylinder head, or my combustion chamber, I should say. But I made a cut in the cylinder head. So I'd like to do something similar. Perhaps I can highlight my sketch plane and sketch my spark plug plane and sketch on it. And I'm going to make a similar sketch as before. I'll put a center line that references the center point of my cylinder. But this is kind of an eyesore, so I'm going to hide this plane and then get back into my sketch. Now I can at least pretty clearly see the center point, but I'll put a reference point there just in case. Of course, that didn't seem to stick, so we'll say that this is concentric. And for reference, I can also put a reference plane. I think, again, it would be smart to show the sketch that I've just hid, so I can have some more references of geometry. So I'll put a point there. I don't actually have to, but put a vertical construction line. We'll make this have a horizontal constraint, another horizontal center line. Nope, that didn't grab, so we'll merge and give this a horizontal constraint to be equal to the other. And then I can grab one of these arcs and give it an equal relation. And so now I've fully defined this without a single dimension. So if I adjust anything about this profile, it adjusts in this sketch automatically, again, for design intent. So I will make this for construction. And I can even convert entities, make them for construction, mirror them over here, but I think we'll do that for some later features. I'll just remake it right now. Center point arc, and just like before, we'll make it vertical. We can go with 3 tangent arcs, and we can fully constrain this with horizontal and vertical. And now, finally, a center line. Well, actually, if I happen to want to change the angle of the center line, I can update it automatically just with a horizontal constraint. So we're fully constrained, and we have even more flexibility should we need it in the future. Rebuild, and I am on the plane above, so I will sketch on this face, select these 4 lines, but not this face, and convert entities. And now we're copied again. So rebuild. And you're probably wondering, why don't we just mirror this to the other side? And my intent here is to have a different profile on the exhaust side, because that's often how they do it in cylinder heads. So to make this, we'll sketch on this face. I'm going to select these 4 lines and convert entities. And in this case, we want to make the exhaust a little more restrictive. So we'll take a series of sketch fillets, and I want to fillet these to a radius, because if I fillet them to a radius, it makes it a little bit more restrictive. So I'll fillet these 4 corners, and we'll go with something like 0.45. And so that will be the profile of our exhaust. It'll be good for turbocharging as well. Okay, with that being said, I will make the same, at least principally the same, 3D sketches that I've done before. And again, we'll make this parallel to the top, and with the tangent arc, make sure that these points are tangent. And let's see if my constraint of 0.2, yep, that works on this end. Let's see if it'll work on this further back profile. So I'll start a new 3D sketch. Yep. Parallel. And tangent. And by making these lines equal, we've essentially guaranteed our 0.2 depth for our valve seat. And it looks like we have no problems with our geometry up here. I'll again start a 3D sketch for our third path. And we'll go parallel to the top of the cylinder head. We'll go to a tangent arc. And again, use that equal relation. Another 3D sketch. That didn't snap with the constraint that I wanted, so we'll add a long Y. We'll use this to be parallel to the top. And our tangent arc didn't work out the way that I wanted it to, so let's have it actually come out tangent. That's better. And we'll make sure that we're tangent to the other side as well. Bringing this up, we'll go with, again, equal. I think we're ready for a lofted subtractive cut, so we'll loft. We'll start here, to here. Well, let's try from here to here to here. I'm getting some kind of profile error that I haven't seen before. Usually that should just select as one entity. We'll see how that turns out. Now we'll use those guide curves. Perhaps I just clicked on it in a funny order. That is bound to happen sometimes. Yeah, looks like we've cut smoothly and the way that we've expected it to cut, so I don't see any problems there. We'll do the same thing and grab our center plane across the cylinder. That's plane 1. Oh, I mean plane 2, and it's not bad to give these planes names. I'll mirror across plane 2 this feature, and it looks like we have no errors or problems. So there we're starting to get what looks like it might resemble a combustion chamber. So we're doing pretty well. Why don't we, while we're at it, cut a spark plug as well. So I'll select this is a plane and I can even sketch on it. So I'll Control 8 and I can give this kind of an arbitrary size of something like 0.5. 0.5 is large. I'll go with 0.45 and extrude cut through all. I'll save. Now why don't we mirror what we have so far, and I think I can ignore this geometry for a while now, so we'll hide the things that aren't necessary in the view, and let's do a linear pattern in direction 1. With all of these features, I think we're bound to get an error with the feature pattern, so I'm going to simply select all the faces that I'm concerned with mirroring, and I'll give them a distance of 3.5 inches. So we'll do a face pattern. I think that's all of our faces. Let's give it a try. And there we have everything patterned. I want to begin now by getting normal to this plane, and let's sketch out a flange for the exhaust. So sketching on this plane, I'm going to begin by going with a fillet. Let's make that by a center point arc, and I'll reference, well, perhaps not this as a center, maybe I'll start with a bolt hole, because our bolts are very important. So I'll start sketching here, and I'll choose all of these holes and make them equal, and I'll choose these centers at the top and make sure they're horizontal. Likewise, horizontal. Now I can give a dimension of something like, let's go with 0.3. And perhaps in lieu of patterning, I can simply add these construction lines so that I can have uniform spacing between these holes, and selecting these and choosing equal. I can now dimension one bolt hole, and we'll say that this is 0.35, and why don't we even make this coincident to this line, and now I can pattern everything by specifying 3.5, and our top holes are patterned. I'll make this one a tad bit closer at 0.25, and again 0.25 away here, and we have the same spacing. So now that our holes are fully constrained, let's generate a flange. Let's use a center point arc to make sure that we can stay concentric. And after this arbitrary center point arc goes, I think I'll maintain a straight line across here. If you wish to make yours kind of curvy or swoopy, go for it. There's nothing stopping you. I'll give this a radius of, actually I'll give this a wall thickness from the hole of 0.25, because that wall thickness might be critical if it's load bearing. And we'll give a tangent arc. And we'll make this tangent arc of equal length. And we'll say that this is going to be 1/4 inch away. We'll take the center and make it horizontal with the end point, and in that way we know we end on a horizontal point. We'll come down here, and I'll add in another, this is a tangent arc. For convenience, I'll switch to a center point arc, and we'll make a tangent arc, vertical, and we'll take a straight line all the way over here. I can add in a tangent arc here, and we can go around that hole like that. We'll merge those so that we're concentric. We'll make these arcs equal, as well as equal here. If I can select the right number of elements, we'll make this end on horizontal by adding a vertical constraint with its center. And then I'll probably want to use the same radius when going around another bolt hole, if that truly is critical. Make sure that these are horizontal, and this may need, oh, this is already horizontal. No, it's not horizontal, so that horizontal relation goes to something different. Regardless, we should be fine here. I don't think that this spacing is going to equate to this spacing, so I'm going to sketch out one more profile, and then we'll be ready to pattern the sketch. So again, we'll use tangent arcs to go around this bolt hole. Make sure that these are equal. This is concentric by merging the center points. We're horizontal here. We end on vertical here. We end on horizontal rather. And that here and here is equal, and we're fully constrained. So I will linear sketch pattern, and we're going on the x-axis, which I think is pretty good. We'll go a pattern of 3.5, and we'll select this entity, this entity, and this entity, and this entity. And that saved us some time and effort. So now we just have to snap this here to fully constrain, unless of course the points Okay, I think this is where we left off after that crash, unfortunately. So all we have to do is focus on fully constraining this sketch. I think the first thing I'll do is take these 2 points and merge them together. Of course, they just don't seem to be able to be merged. So perhaps I'll add in a dimension to fully constrain, and we'll go distance of 3.5. And that does fully constrain our sketch, and it's exactly what we want. So I'll just leave it there. I'll get rid of this one entity, and we'll use a center point arc around this point. There we go. Add in a tangent, and we'll make this end on vertical, which means we have to add in the horizontal constraint. And then we'll add another center point arc around this point, so we're tangent, and then a tangent arc, which will be tangent on both ends and of equal radius, and that should fully constrain. Okay, so we've got a fully constrained flange sketch. Let's extrude. I want to extrude a distance of 0.25, but before I select my contours, I would really like to select each of these edges. Looks like my line is getting in the way of all things. I guess I will sketch out, which is probably as fast as selecting them, really. And then I can linear sketch pattern. Which hopefully saves me a few clicks, maybe not. 3.5. And so now I've got these all selected. And now one dimension to constrain at 3.5. Now I can add in a extrude, and in contours I'll select this and go 1/4 inch out. Very nice, that's exactly what I want. So there's our flange on one side. Now I'd like to do a weight reduction. I don't know if you've seen those memes on the internet. Weight reduction, bro. So to reduce material, I'll sketch on this face, and we're going to sketch out the following weight reduction profile. We'll add in a center point arc that will go around this, and I'll choose a tangent arc here. Perhaps I can give this a distance of 0.25. And that, of course, is not concentric, so that won't work. Perhaps I'll choose concentric, and that fully constrains by itself. So we'll make it vertical, so we end on horizontal. Again, with this, vertical. Okay, with this profile sketched out, I'm going to add another line along the bottom here. Now, a lot of profiles like this in sketches don't seem to pattern that well. So we might be able to pattern this and then have a difficult time fully constraining. We'll see if that happens here. We'll pattern, and in the opposite direction we'll go 3.5. And we'll pattern this that many times. Yep, we don't pattern that well. And I think one of the problems is I can even take one of these constraints away and then say something like, I want this point to be vertical, and somehow it still isn't overdefined even though we just took that away. So this is not patterning well. What I would prefer to do then is simply mirror it a few times, which would still save us some sketching. So we'll mirror the following entities about this line. And I can make that coincident. It's not requisite to fully define center lines. I like to do it out of good practice. So again, we'll select. Now, it looks like it converted this into one arc. That could be problematic, so I'll simply trim, and add two sketch elements. Now I can mirror about this line. Finally, tangent arc, and I can finish up this profile by simply making both concentric. We're pretty fully defined, and then a vertical to finish it off. Now it's all arbitrary how I want to finish up this profile. Probably in like manner. Equal. Equal. Horizontal. So if both of these are equal, then I simply need to add a horizontal constraint here. I'll make arbitrarily a point at the center here, and we'll go vertical. We'll take this arc center point and make it vertical, and we're finally fully constrained. So I'll make this endpoint vertical, unless of course that overdefines us for what seems like no reason. Yeah, I certainly don't understand why that would be overdefined, but we can define it by some other way. So for tangent over here, make it tangent here, and of course we are overdefined. So I'll simply choose equal over here since it's relatively arbitrary at this end anyways. And we're fully defined. Okay, let's do a revolve cut along this axis at 90 degrees. And there we have weight reduction. So let's mirror some of these features across the right plane. And we'll also choose this flange. And we can simply use convert entities to fill in some of the gaps that we see here. So sketch on this plane and choose convert entities. Well, I guess I have to sketch, convert entities, here, 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 and simply select the faces that are sunken in from the surface. That's better. And with these faces, we'll convert, giving us a lot of contours. So we'll extrude to surface. And there we have our exhaust flange as well. So now that we've got these flanges and everything mirrored, perhaps we should work on some of the internal parts of the cylinder head. And one of the first internal parts is perhaps the coolant channels. And this can be a tricky one with a lot of tricky geometry. So let's get started. I think I only have plane 1 and plane 2. I think I've got some more potential for making another plane, so why don't I grab one of these sketches. That should be it. I'm going to show that sketch and make a plane with respect to the center of my valve, and that way I can very easily see the profiles of my intake and exhaust areas of my cylinder head. So make a plane and select my center here. And now I can cut my view on that plane, and I can also sketch on that plane. So I'll call my valve center plane plane 3 and Control 8 to get normal to it. So those are my two profiles, and I can see that I really don't like the way that this exhaust geometry looks. So perhaps I want to adjust that real quick. I'm going to go to Cut Loft 2, which is my exhaust, and edit my feature. Whoops, it looks like I'm actually Cut Loft 3, which makes a bit more sense. And I'm going to, my start and end constraints, normal to profile, and that should fill me in. And also, because we had good design intent, it fills in all the other ones without any worry. We still have a little bit of a hump there, but I think we'll be okay just for this example. So I'm going to sketch on this plane, and we can start by looking in this area. I'll create a point, and I really kind of need just an arbitrary place for this point, so we'll do something like 2 inches by 1.5 inches. And maybe I can do a circular center point slot. And that will be my coolant channel. So if I apply some dimensions to this, I'd go with something like a thickness of 0.27, and I'll add some construction lines so that I can reference some angles as well. And we'll go with something like 45 degrees here. And maybe I can go 20 degrees off horizontal. And then perhaps I can give it an inner radius of something like 0.58. That would be a pretty decent coolant channel. I could probably go slightly larger, maybe 0.3, and a smaller radius of 0.5. And instead of 45, I can maybe do 60. Yeah, that's not bad. Okay, so that would be our coolant channel. And why don't we extrude that? And when we extrude, I want to go something like, it's kind of arbitrary, but we're going to have to maneuver our way around some of the features that we haven't built yet, and so that requires a little bit of thought. But let's offset from surface, and we'll go something like 1/2 inch. And then in direction 2, I'll do the same for consistency. So there we have the coolant channel, and I can immediately mirror that feature across the right plane, and that will be excellent. So we've got our coolant channel running through the center of our cylinder head. Now I want to work on my coolant inputs that flow through the engine block into the cylinder head. So let's get started on that. The first thing is I want to be able to see my coolant channel. So I'll change my view to show hidden lines, and there I can see the lines for my coolant channel relatively easily. So I'm going to make some slots. We'll sketch on this face and make our center point slot. Now I want to line up to my coolant channel relatively well, so we'll choose a tangent relation, but of course that's a tangent relation on the wrong side. So we'll go here and say tangent, and we'll choose this arc and tangent. And I can give this a decent thickness for our head gasket, so maybe we'll go 0.19, something like that. And then all I have to do is give this a thickness to fully constrain. So I can go with something like 0.2. Oh, that didn't work, obviously. So 0.3 it is. So that will be 1. We can pattern this as a feature or as a sketch, and I would much prefer a sketch. It would be simpler in this case. And that snapped onto something that I didn't want it to, so we'll make it horizontal. And since that's arbitrary, I can make that any length I want. We will mirror this slot about this, and then mirror these two slots about this. And now we can pattern, but we want to pattern on the y-axis rather. At a distance of 3.5. These entities and 1 dimension to fully constrain. Since we're adding a lot of 3.5s, you can even make a global variable, and so you can change that from the variables menu to have all of these updates simultaneously. And it's a great way to avoid rebuild errors when you rebuild. So let's get these coolant lines, or these coolant slots, connected into our internal coolant lines by features, extruded cut, and since we're tangent, we have the luxury of not caring how far we blind. We'll choose up to next and select that. So now, if I change this into real graphics here, and I cut my view, you can see that we don't cut anything that we don't want to, because we simply go to the next surface and stop. So this is ideal for coolant lines, and we can smooth these edges out with fillets later, because sharp edges probably wouldn't be realistic for the manufacturing process to make this cylinder head. So with our coolant lines all cut, we can begin to even hollow out the cylinder head. So let me get started with that. I'll hide this plane because I don't think it's that necessary. I can always access it from the history tree. We'll grab, and I don't need this sketch currently, I might need it in the future. So to get started, let's grab the front plane, and I want to hollow out the top of this so I can start making internal features, particularly for the valve train. I'm going to start a sketch on this plane. One thing to keep in mind, if I were to cut my view on the front plane, I don't see the profile very well that I want to cut out. So I will instead cut along probably my valve center plane, plane 3, and there I have my valve in view. So it is kind of fun when you can sketch on a plane that you're not viewing the cut from. We'll go with a midpoint line on the origin, and we'll give that a distance of, let's say, 0.5. I just want to hug this profile almost arbitrarily. How about we take a, probably in this case, a 3-point arc, because they're so flexible with this sort of thing. And we'll make sure that these arcs are tangent. And I'll do a vertical line. And I can give this vertical line a distance, I think 0.6. Allow this line to hug it pretty well, except for, of course, I've put my arcs in a position that I don't want to. So to avoid that, I'll first give this 1 point, let's say 1, 2, 5, and I can give my line a dimension of now 0.6, which it almost seems naturally there already. If I scoot this back over and I move this point, you can see now it's almost like a spline in that I can have the flexibility to define this the way that I need, but I have the flexibility in, without question, fully defining it. Alright, so with this profile, I will perhaps dimension off of this edge something like 0.125. Maybe that cuts it a bit thin, so we'll go with 0.4. That looks about right. Now I can give this a radius, and some of these larger radiuses are a little bit more difficult to visualize. Maybe I can give this another smaller radius. Well, they're both 3. I think I'll make this one a bit larger. We'll go maybe 5. You know, whatever fits our profile decently well is fine. And since our exhaust is a different profile than our intake, I'll see how well I can match that profile over here. Again, we'll add tangent. Come on, you stubborn arc. Okay. I guess I will add that tangency later. I'll choose vertical of equal length. And I'll take the midpoint of my line, make it vertical, so that they'll be the same distance. And we'll make these tangent. And now I simply choose some groups of radius features that I think will fit this pretty well. So 1 is too small. Let's try 3. If I try maybe something like 7, which is too large. 5 is too large. 3 works. Let's try 4, too large. 4.5 works, but wow, this is getting stubborn. So 3.25, that seems to hug things pretty well. 2.75, so we'll go with 3 over here. Okay, with that being said, features, extrude cut, we will offset from surface, and of course I can't choose this surface because it's been cut, and so I'll choose this surface at a distance of, say, 0.25. And now that I'm out of this, I can undo my cut and edit so that I can add direction 2, offset from surface, and we'll go again 1/4 inch. So now we've got our cylinder head hollowed out. We'll save. Just in case it crashes, of course. Now, I want to begin adding some VALVETRAIN features. So to do that, I want to add a sketch on my valve center plane. Of course, that was plane 3. And let's even cut our view on that plane. And then we'll sketch on plane 3. We'll make a vertical center line and an angled center line. I can even snap this center line to be coincident and horizontal for some constraints. Now I'll show some of the geometry that I've used before. So I know that this point is one of the points that I've referenced to be an exact center to my valve. So I like this even better. I'll show the sketch and make it coincident. So I've got a fully constrained line here. Now I have the luxury of choosing an angle at which I want to have my valve. So let's do something shallow like a 5-degree angle, and I'll say that my valve will run 5 degrees off of horizontal, and I can end up, of course, centered on this point. But if I'm looking at it, I think the actual best geometry to use was the other sketch after all. So I'm going to grab this sketch and show it. And from this point, I can grab that, there we go, coincident. So now our valve will end up central at this point. I'm going to need this. This surface is not symmetric to this surface. So at some point I'm going to need a plane that will reference both sides. So I'll mirror, and we'll mirror this line and this line about this line. Rebuild. And now I'm able to make a plane. So I choose reference geometry plane, and I can choose my valve plane by simply selecting this line and its endpoint to get a plane that's normal to this line. Now I am able to sketch on this plane. So we'll make a sketch. The first thing I'll probably make something on the top end here. Again, still have this sketch showing, so I can grab this endpoint and my circle center and make them coincident. And that way I know that I am centered on my on my valve axis coming up here. We'll give this a diameter of something like 0.75, and then I can choose an extrusion. I can probably go some, and I can probably, well, yeah, I'll do an extrusion. And let's offset off of the sketch plane. And of course I've aligned with the wrong side. So I'm going to align it with the right side. I'll break this coincident, grab my circle center, and we'll pierce this line. So now we're on the right side. And in our extrusion, instead of blind, we'll offset off the sketch plane a distance of 2.8. And now I can up to surface, and I'll choose this surface here. Here I have the beginning of a valve train, and I don't think I actually need to be that high. So maybe I can lower that down for a bit of a more ideal profile. 2.5 inches is a really friendly number. Now undo my view, linear pattern down this direction, and we'll go a distance of 1.2. And we'll choose there we go. Gave me trouble for a second there. We'll choose not this face, but rather this edge if I can ever click the right thing. At a distance of 1.2. We'll do 2 because that's my valve spacing. And we've patterned that, so let's pattern that again. And we'll go a distance of 3.5. But instead of this face, of course, we'll go here and add in 2 more. And now we will mirror across the right plane. Oh, but since we're not symmetric on these surfaces, it will not work. We'll get an error. So that's at the point when I need to create another plane. So I need to create a plane on here, this line. So reference geometry plane, and just grab the end there. And then I'll do the exact same thing. I'll sketch on the plane with a circle, and I'll take the circle center and put it at the end of that line. We'll make it coincident, and then I can give it a diameter of 0.75, I believe it was. And now I can extrude, offset it from my sketch plane at a distance of 2.8, and again up to surface. And there we have the other feature. But of course, I adjusted this to 2.5, which I think looks much more ideal, much more space saving. We'll do a linear pattern along this edge at a distance of 1.2 in the other direction using two features. And now we'll linear pattern, distance of 3.5 in the other direction with four features. And we have the beginning of our valve train. So I'll grab this face and we'll sketch on this face. We'll make, how about a spring perch? So our valve spring will have something to fit into. To do that, I'll make two circles. And I'll give this outer circle, say 0.7, and this inner circle, say 0.14. And I don't seem to be aligned properly. That's because I'm not referencing my center point here. So grab this and pierce, and that's better. We're concentric on the valve. This would be an axis that our valve would go through, and we're concentric with our circles. So we've done everything correct there, thankfully. Why don't we extrude cut? And we'll extrude cut. We probably only need to go 1/8 of an inch. And now I can linear pattern along this direction. And again, 1.2 and two features. Now I can linear pattern again, this time utilizing 3.5 inches along this direction. And something, oh, there we go. Let me go in the other direction. And now I can mirror this because these should be symmetric. The surfaces are not, but what we're referencing should be symmetric. And so this is a pretty good test to make sure we've achieved proper symmetry. We choose the right plane, and we have no errors. So indeed, we have a match. Now, I want to cut my valve guide holes. So again, grab the plane 3 that has my, well, not plane 3, but plane 4 that has my valve angle. I'll sketch on that and Control 8 to get normal to it. And I'll add a circle. And I need to reference this line here. And what do I want to have my valve guide diameter be? I'll make this 0.1875. We'll extrude cut through all. And so now I have my valve guide coming straight into this feature. Let's pattern that. Again, 1.2. We'll go along this direction. Two features. We can linear pattern again in this direction. 3.5. And we'll add on two more features. And we're also able to mirror this across the right plane. Done. So now we have our valve guides and a good start on our VALVETRAIN features. We also have our holes for the spark plug on the upper engine. So why don't we get started with our camshaft retainer. I'll sketch on this plane. It's nice and easy and convenient and at the angle we need, so we'll start a sketch. Control 8, and I'll create a center rectangle. I know that I want to be aligned centrally to my valve center. So there's the center of my valve. We'll make that vertical. And I want to dictate this according to my oil channel. So, because I want to have an oil input channel coming in, and I want to have that line be as straight as possible. So I have to think about where do I want to position my oil channel with respect to the rest of my cylinder. And so to think about that, let me show hidden lines. And there I can see where my cylinder circle is. And perhaps I'll have my oil channel. In fact, perhaps I should just cut my oil channel now so it's easier to deal with later. So I've exited my sketch. I'll grab this face and sketch on it. I'll have my oil channel here and here, and I'm going to go something like 1 inch, and then that would be about right. What diameter do I want to make my channel? I think I'm going to go with something basic like 0.2. And now I can use center lines to constrain the other side. And so if something were to change, I would be able to change it quite easily. We'll say collinear equal, and then make them equal with diameter as well. Let's do a linear pattern. We'll go down the y-axis, 3.5 in the other direction. And a dimension to constrain. This can be an arbitrary dimension anywhere. Again, use a global variable if you've got more time than I do. So we'll cut extrude, and we'll go through all. So now that I've got my oil channel cut out, I can now position my camshaft retainer a lot more easily. Although I'm not seeing my oil channel, so what I'm going to do to see my oil channel is take my cut extrude and perhaps just move it decently far up my history tree. Probably by another cut extrude would make it logical. Now I can see and reference my oil channel, so I'll get back into my sketch. And if I can reference, looks like I can't. So I'll take the sketch that I made my cut extrude and show it, and that way I can reference from some of the geometry. So we'll take the center point and my center point here, make them horizontal. And I can take my valve center point, which is here, but I want to grab that end point. Perhaps I can grab that line. And well, I want the vertical relation, so let me try again. I'm going to grab that very center point and make it vertical. Now with a fully defined center point here, I know I'm on the dimensions that I need. I can go ahead and assign dimensions to the rest of my camshaft retainer bracket, I guess you would call it. So perhaps I can make this something like a 1/2 inch thick. And I'll go 0.9 inches in this direction. Now I can features, extrude, and I'll extrude to surface here. And in direction 2, I'll probably want to continue up a little further. So I'll say direction 2. And I think up to surface here. Would be nice because then we end about level with the top of the cylinder head. One other thing that I should add to my sketch now that I look at it is I can grab these 2 points and convert entities. And now my oil channel is preserved. Although it would appear that we come out at an angle. And I don't think I like that angle. If you can't see the angle, let me show you real quick. Yeah, that's kind of a rough angle, and it would be beneficial to keep it going straight. So, edit the sketch again. I'm going to take out the converted entities, and we'll create that channel with some other way. Since we reference this, I cannot drag the oil channel to be below this bracket because it's referenced. So instead, I'll choose this sketch and simply recut extrude. And this is probably the most optimized for time approach that I have. And I can recut extrude that. And so that references nothing. So what I'll do, now that I've done another cut extrude, I'm going to temporarily roll back and do my linear patterns. We'll choose this edge, and we'll add one more feature. Now again, these features are not symmetric, and so I cannot mirror these across the right plane for the same reason I couldn't mirror this feature across the other plane. So I'll simply grab the other plane that I've made, not plane 4, but it should be plane 5. Actually, I sketched on this plane, so let's do that. Sketch here, and I'll get normal with Control 8. And now I've got these wonderful sketches that I can reference. So I'll make my center rectangle as I have, and I can choose my center point if my mouse will let me here and choose vertical. I can choose my oil center point and choose horizontal. And with this fully constrained center, I can give it the same dimensions. Now I would love to just reference this thing and say equal, but I cannot because it's at an angle, and so the angle can affect the accuracy of our dimensions. So I'm going to play it safe and actually give it dimensions instead of trying to get it to update automatically. Features, and we're going to extrude up to surface here, and then in direction 2, we'll extrude up to surface here. I'll choose linear patterns. In fact, one thing that I can do that might be a little bit more slick and reduce our history tree is I can drag this above linear patterns. So now we're doing a linear pattern after. I can edit the feature and add in this extrusion. So we're covering 2 things with 1 linear pattern. Now I can move my cut extrude down, and our oil channels are automatically added in. So I've got our oil channels going through our brackets, and I would like to perhaps sketch on this face. We'll Control 8, and I want to add in my cutout for the camshaft. So let's say we want a camshaft to have a diameter of 0.5, and we'll make our center point coincident onto our valve axis. Add in a line to close that profile, and I will features, extruded cut. We will go up to surface, and I can also, if I want to, go up to this surface, but I think what I'll do instead is edit my sketch. Well, I have to go to my history tree and edit my sketch plane to be on this face, and that way I can run the camshaft through this face. I'll probably later need to figure out how to run oil to this whole thing. Let's do a mirror, and I can mirror this feature across the right plane. And we're done. Alright, so with our view this way, I want to make perhaps what we think of as a wall going to all of these, to this wall. You may wonder why I'm doing this, but there's lots of benefits as we progress down the line, so maybe you'll have to watch indulgently. I'll choose a corner rectangle, and I'll move from this inner geometry to this wall, and we'll make this collinear. And I think I'll do a linear sketch pattern that covers these profiles, and I'll go 3.5, but of course I want to do that on the other axis, so let's say y-axis, 3.5, and then we'll continue adding features until we're at the very end. One dimension to fully constrain. We'll extrude up to surface here. Now I can sketch on this face. And I will do the same, perhaps starting at this point and going to this point. Make this coincident. And now I can linear pattern entities, not on my x, but on my y-axis. 3.5 in the opposite direction. One dimension to fully constrain. And we'll extrude to surface. And that is a huge time savings that we're looking at by being able to add in those walls early on and very quickly. So this will be exciting. I'm going to get normal. It's looking good. I'm going to save this file. Okay, I'll highlight this face, Control 8 to get normal to it, and then start a sketch where I'll draw 2 circles, and this will give me the beginning of my freeze plug profile. I'll go to display style and show hidden edges, and in that way I can take my inner circle and make it tangent to the top of my coolant channel, and then tangent to the bottom. And I can give it a dimension of something like 1/8 inch thick between these 2 walls. There we go. And now I simply need to position this, and to do that I'll grab, again, center lines, and I can say that these are the sides of my exhaust outlets, and so I know I'm central to my cylinder if I make these things equal. And we'll go vertical. Get back in my normal view and choose up to next. Or I can switch the direction and then up to next shows up. There we go. And again, sketching on this surface. I'm going to choose there, a circle. Make it equal. And again, extrude a cut up to next. And there's the channel that accesses our cooling channel. So we'll be able to put a freeze plug in there, of course, adjust that to whatever size is required. We can linear pattern this. I'll choose the extrusion and the cut, which I may have to go to my history tree. We'll space it. And those are the freeze plug ports on that side. Let's add them in over here. Simply mirror across the right plane. And they're fully added on this side as well. Now I can start thinking about my coolant channel, and the big thing is, where is my coolant going to exit from? So let's cut our view and make an exit at the back of the cylinder head. We'll sketch on this face and convert entities. And convert entities. Choose a line. I'll make coincident, but perhaps instead of right there, I'll choose this arc and the endpoint of my line to make coincident. And then from here, I can add a tangent relation. It will be coincident and fully constrained. We can add another line that we can make coincident and tangent, coincident, and I can trim my entities here and here. And I've got a little bit here and here. Now that we have a single enclosed space, I can extrude cut. And I can go an 1/8 inch. And we have a chamber where we can gather all of our coolant. So I'll redo with 180 degrees. And we can view that chamber where we'll collect coolant at the end. take this face, sketch, sketch, show hidden lines, and from here make this vertical and tangent and tangent. And of course we're going to want to fillet the exit here, and so we don't want to be tangent to the top and bottom. So I'm going to make this a reference, and now I can add a certain wall thickness so that I can guarantee if this changes dimensions, I can at least guarantee something like a radius on the fillet of something like 0.15. And now I can extrude cut to next. And if I switch back to the normal view, we can see that we simply stop at that channel that we've cut. So now I can add a flange on this surface, and I think I'll hide some of the features that I'm not using anymore, like these planes, if SolidWorks will let me. And now my sketch view will be a lot cleaner. I'm going to start with a center point arc, or in fact, maybe it's easier to reference this with a center point. Then we'll go here. I think what I'll probably do is make this point vertical. And there, tangent, horizontal, tangent, vertical. Make these equal. We'll take this and make it, if Smart Dimension will come on, 0.5, and that's not pretty, so we'll add a few more relations so we'll move a little bit better. There we go, 0.5. I'm going to add in a bolt hole that I can dimension to something like 0.1. We'll give this a thickness to be consistent of 0.1, and I'll draw a center line. We'll mirror. Add in another center line. And make them equal. Now when I extrude this, I realize I don't want this to be filled in, so we'll convert entities. Now I'll have this center line be coincident and coincident. Let's do something like a 1/4 inch. There's an output. Now want to focus on some of these oil return lines because we've got oil supply lines that come in through here and work the camshaft, and we can even add a sprayer later on that would, spray the lifters. But here we need a return for the oil because the oil is coming in and doesn't have anywhere to go. I'm going to start down here. That'll make the patterning a bit easier. Sketching on this face. Make it tangent. And I'll make this as a reference for construction. And again, we'll give this, say, a thickness of 0.15. Perhaps we want to go a little thicker. Maybe we go I should say thicker in this direction, say 0.05. That would work. Now I am going to need a sketch on a plane that can intersect this. So we'll say features. Well, I might be able to get away with sketching a path. It's not on the right plane. So I'll say plane 3 will be fine. Make a line here. We'll make an arc, a straight, and another arc, and a straight. And we're coincident on the end, which is where we need to be. We want to have an angle here, so something like 135. We'll give this a radius of, say, 0.5, and we'll make the radius between the two arcs equal. We'll probably need a linear distance here. We'll say something like 50 thou, 0.5, or 0.05 rather. Then we'll need a distance, and we'll want to have a distance that doesn't interfere with our cylinder. So if I grab a point, we'll say something like 1.85. I need this to be for construction, this outer part, because it's only for reference. And we'll say features, swept cut, this profile on this path. And that saves me from having to create a plane because they can be a little bit painful and busy to create. We'll do a cut view. And yeah, our path looks good. Nice large tube coming out. That's a little bit too large. So I think what we'll do instead is have this combine into two and have it big on one side and two smaller ends, and so we'll have more appropriate head gasket room now that I look at it. And that's the beauty of parametric modeling. You can go back and work on it if you have to. So we'll simply go back into our sketch and make this, say, 0.15. Now I can mirror what I've just made. We'll take the sweep and we'll mirror it across the right plane. So now we've got kind of a nice Y shape, and that will be our coolant outlet. So in fact I'll grab the mirror and let's linear pattern this. We'll go into this direction. Add one more feature, 5 total. So we've got 5 inputs, 5 outputs. It looks like it's calling for face, so we'll delete that and we'll do the mirror and the sweep. It looks like the mirror covers both. So now we've got a series of oil outlets. I want to add some fillets. If you look at the cut view, we could do with a little bit of a downhill to get the flow started a little bit better. So the first fillet that I'll do is on this edge, and we will fill it to say 0.5. Okay, so the next thing that I want to do is fillet these oil return faces, and being careful not to fillet my spark plug tube. There. I want to fillet, and we'll fillet this again because this gives us a nice general depression, and then I can say something like 0.25, and it will open us up way big so that we can have some very good flow on our oil return. And we'll be careful not to, again, fillet the spark plug tubes because that's what we don't want to do, only our oil return. And there we've got a nice big area that we can move a lot of oil through. So that should work out very nicely. Okay, now that we've dealt with our oil returns and we've put the fillets on them, I normally would save this for the end, but it seems like a pretty good idea to make sure that we fillet the coolant outlet areas as well, since we've just made them. So as we discussed before, and then I can finish up the fillets on the rest of these faces at the end, because you do want to save most of your fillets for the end. We'll simply add fillet up here and here, and that will help smooth the transition from the coolant channel into this chamber. And then we'll do the exact same. Have to cut it in the other direction so we can see the face. Go down to 0, and we want to add, we guaranteed with making this offset dimension of 0.15, we guaranteed a fillet of at least 0.15. But it looks like it's allowing us to do larger, 0.25. And I'll fillet this face as well to hopefully encourage good flow. We're looking pretty smooth there. Again, we'll finish up the fillets at the end of the design process. I want to turn my attention to these flanges. They look good, but we're going to be putting some bolt holes to actually bolt the head to the block. And when we do that, there's not going to be much room for these exhaust bolts. So to compensate, I'd like to make these studs instead of bolts. So let's begin doing that. We'll start by clicking on this face and sketching on it. We'll bring up a menu for converting entities. And we'll click everywhere that we want to place a stud. Looks like my computer is lagging because I think the real view graphics with recording my screen and everything else is sort of bogging this computer down. I want to extrude, and let's extrude, say, a distance of 1.5. I want to add fillets, and fillets will allow us to get some cosmetic mill threads on there. But before I do, it would probably be smart to mirror it because it may not mirror when I have fillets on there. So I have mirror across the right plane, and we've already got our extrusion selected. So now we've got some general studs. I'll simply grab my chamfer, we'll chamfer every end edge. Move this dimension to a generic 0.1. And there we have some studs that we can cosmetic thread later on. From here, after we've done the fillets, let's focus on the parts where we actually, bolt this to the block. So the first thing that I want to do is sketch on this face, and I think I'm going to sketch down here so that it will pattern easy. I'll create two sketches, and this one, I'll select this edge and make this tangent. I'll take my whole center and make it coincident here. And then I can take that point and make it horizontal. Now I can take this inner circle and say give it a, well, I'll just give it a straight diameter because that would be more of a critical of 0.4. And I'll make this outer circle for construction. I'll convert entities here, but this should be for construction. And mirror this circle across this line. And we're fully defined. So these will be the bolt holes that we bolt the head to the engine block with. Let's do a pattern, and not on the x-axis but rather the y, 3.5 inches. And we'll choose these two entities. With a pattern of 5, one more dimension to fully constrain. Again, if you have any degree of seriousness, use a global variable for this dimension. We're going to extrude cut, and we can simply go through all. And those will be the bolt holes. So here we've got our oil supply, oil return, coolant, and bolt hole. But we'll need to reform a lot of this up here to make sure that we're compatible with bolt holes and make sure that we have a surface large enough that the head of the bolt can rest on. Let's get started with that. The first thing I would like to do is sketch again on this face. And I'll add another circle. We'll give this a dimension of something like 1 inch. Again, I'll convert entities and make sure that this is for construction, and mirror about this center line. Then I can sketch pattern my entities, not about the x again, but about the y at a distance of 3.5. And we'll go with 5 features off of these two circles. One more dimension fully constrained. And now I can cut to surface. And we'll choose the top of our flange. There I have a rather rough looking cutout, but a bolt head should be able to fit within that dimension. I'd like to begin to fill this surface in. So again, we'll fill it in by sketch. In fact, I think I will exit this sketch because I don't think I need it. I'll grab this previous sketch, features, extrude, and instead of from sketch plane, I'm going to extrude from surface, and I'll extrude to surface here. But the problem is this sketch can't be stopped at that surface. So to avoid any errors, I will indeed create a sketch on this face, convert entities from this sketch, and if SolidWorks will allow me to get normal, I will make this side for construction, and now I can do that extrusion. And again, I'll be extruding up to surface here. I have to select my contours I wish to extrude with. I guess that contour works. And that's much better, except I would like to adjust that sketch so the bolt holes are still there. I can probably simply convert entities. And of course, it looks like it updated pretty well. I was scared I'd have to select my contours again, but it seems like it picked it right up what I wanted to do. I'll do the same over here on this other surface. I'll sketch. And let's grab the sketch that we'd made. We'll convert entities again. And it looks like these construction entities didn't convert, so I'll hit Control Z and choose this sketch instead. Convert entities. And we'll make sure that these are for construction. And it looks like all the entities I need converted, so we'll features, extrude, and to surface. And that turned out very nice. However, for some reason, none of those holes seem to have converted the way that we've wanted them to. So I better edit my sketch. And I'll do the same of converting entities. I saw the slider part inside and thought that maybe some of these holes already had a converted entity there for some reason. Okay, now I should be able to rebuild and see our bolt holes. That's starting to look pretty good. It's starting to look a little bit more like a cylinder head, so I'm going to save. And so now that our patterning is done, I want to continue this wall around, and of course I can route the wall this way or this way. I think it's kind of a cool design feature to route it this way because our valve cover wouldn't necessarily be covering our cylinder head bolts. That would imply that you could take the cylinder head off without even touching the valve cover. That's kind of a cool idea. So I'm going to take that and let's sketch on this face. And I'll choose a center point arc that I can run all the way around. Make it coincident. I'll choose another center point arc that's also coincident. I'm going to take a center line, and this center line is simply made to measure, so that if this distance ever changes, it can be captured autonomously and the rest of the sketch will update with it. We'll set these two center lines to be equal so that we'll automatically have a consistent wall thickness. Now I have to close my profile. That's looking good. I'm going to extrude. We'll extrude up to surface here, and in direction 2, we'll extrude up to surface here. That's looking good. We'll take this pattern and go in this direction. And we'll choose this feature. Here we go. So we'll say 3. Now I can do the same thing over here. Maybe I'll just sketch on this top face. There we go. As before, going to choose the center line and make them equal for a consistent wall thickness. And that fully constrained the sketch except for this point. Now I can close my entity. I think you'll agree it's a lot of work to work out these fine details on how to close up the gaps that we need. I'll extrude to surface. And now with that corner treatment, I believe that I can mirror across the front plane. And I've already got that feature pre-selected. That looks good. Let's mirror across the right plane, and these features are already selected. But it looks like because of this surface, we are not able to do it since it is unequal to this surface. I'll choose this plane once again. And sketch using a center point arc, choosing the same features I have done before. I can make an equal relation to this edge, which will save a little bit of time. And close this profile. The relations that we've added have fully defined the sketch. Features, extrude, and we'll go up to surface here. Now I can choose the front plane for a mirror, and we'll choose this as a feature. And we're mirrored. So I can save that document. So that's part of our cylinder head. The other thing, it looks like I need to do the same over here. So there we go. I'll choose this area to work on. Sketch. Again, we'll use the edges for an equal. And I can extrude up to surface. And pattern in this direction. There we have the beginning for head bolts. Again, I'll save this document. I'd like to do a little bit of a cleanup. Looks like everything patterned quite well. But I'd like to sketch on this face. And I can either extrude cut to make this smooth, or I think what I'd actually prefer to do, now that I think about it, is maybe add a little fillet support down here. So I'll do that on each of these 4 corners. That one, for some reason, does not have that feature. I sure do like symmetry. So without much investigation, I am going to sketch on this face a circle. Again, we could probably trace back exactly what happened in the history tree as to why this doesn't, but I want a quick solution for as far as this video is concerned. So I'm going to extrude up to surface here. And that way they'll be the same length, same dimensions. And now I can roll forward into my fillet, edit feature, and choose this edge as well. And that looks pretty natural, and it would be a nice support for that bolt head. Again, Control 7 and save. I want to also clean up this area, because as we have a gasket moving through here, we want to have a nice, clean, sweet path. So I'm going to sketch, and I only need to work on one of these. I'll choose a 3-point arc. That'll make tangent. So we'll have a nice smooth edge. Tangent here. Tangent to this edge. I need to define a radius. I think a 1/4 inch would be pretty good. That should work. Convert entities here, here, and here. Finally, I can trim. And we have a profile that's enclosed right here. So again, extrude to cut up to surface. And that looks pretty smooth. We'll take our front plane and mirror that cut. And we'll take the right plane and mirror again. And we have a very nice, clean profile. Appears I'm missing a hole here. And that was, of course, from that extrusion that I had made to make that little shoulder. So let me come down here and rectify that by editing my sketch. This time remembering to convert entities on this hole. And now we have the bolt hole like everything else. Again, Control 7, I'll save that document. As I've cut out this profile, I'm going to have to start worrying about this upper profile because I need to put a valve cover gasket on this face. And so I want to have more of a smooth profile. So this, if I fillet these edges, it will be part of our design that we're working on. This would be important. So I'm going to choose the edges that I wish to fillet so that I can have a much more smooth transition. And that's pretty good. Now I need some bolt holes for my valve cover, and I've got more space inside than I do out right now. So I'd like to add the bolt holes on the inside, and it can be typical for valve covers to be bolted from the inside, so I don't think it's too big of a deal with design to do so. I want to choose rather a center point arc and say that my center point is along here. Now this is fully defined because I snapped onto that midpoint. I want to see what kind of radius I'd be pulling, and that's probably larger than I need, so I'm going to define this not on the center point of this arc, but probably by something like a dimension of 0.26. I'll make that coincident, but rather I'll probably do something like 0.5, a little bit smaller. I'll make a circle, tangent, tangent, and we'll give this a profile of something like 0.25, like a 1/4 inch bolt. Now I want to mirror, so I'll use a center line, again get normal, and if I can reference this whole center, make that coincident, and mirror this and this. But actually, before I do, I would be wise to use a 3-point arc along here. Make that equal, because I really want to have a closed profile. There's our closed profile. So now I can mirror this this across this line, and we're fully constrained. Now I can pattern, not on the X, but on the Y, a distance of 3.5. And of course it doesn't let me do a box select. So I'll choose this, going in the other direction. Oh, here we go. And one more dimension to fully constrain. Again, use a global variable if you're serious about this model. Features, extrude, up to surface. Now it wants us to choose contours because I've got a tangent relation, so we'll choose this inner contour and this outer contour. And we'll have to do that for all holes. So those will be the valve cover bolts. And because we need to do this on the other side as well, choose this face, sketch, and we'll replicate the sketch on the other side as well, again due to the asymmetric surfaces. So grab my 3-point arc, and I used a center point arc last time, so I'll just merge the center point. I can choose equal over here. And equal. Again, by fully constraining without using dimensions, we are much better off. Tangent. Mirror. Actually, I should convert entities here and here. Trim. Now with my closed profile, I can more effectively mirror. Let's, I want to experiment. I want to do a extrude right now, where I can choose my contours. We'll go up to surface here. Now I have less contours to click if I linear pattern this, so I'll grab the edge that I want to go as direction. There we go. Then I'll save that. Okay, we've got another thing to add, and that would be the groove for our gasket. And there's several gaskets to choose from. I mean, you can do like a carbon gasket or even some crush, but I think it's very common to have a valve cover gasket that would be more of an O-ring shape that's preformed to a certain profile. So let's base our gasket off of that. So what I'll do is get on the right plane and cut our view on that plane. And from the right plane, sketch. Choose this edge to make coincident. I'll choose a horizontal relation, and I'm going to do less than 180 degrees on this arc because a lot of times you want to have that compression on the gasket. Of course, you can also say you got a flat cylinder head, or a flat valve cover rather, that could compress it half the way. So whatever you do, if you actually want to spec this thing out, Parker Gaskets has a free PDF guide that you can just download, and they've got really good material on what kind of compression you want for a static O-ring or dynamic O-ring or something like that. So take a look at that if you actually want some design references. So 0.1 inches seems like it's pretty good. We'll give this a radius, maybe 0.075, and then yep, it looks like we just want to give a height to that arc center. That would, I'm pulling an angle out of that, so we need to select only 2 points, and we'll do something like 0.025. Looks good. Looks good. So we'll rebuild, and now let's make a sweep path for this profile. Again, sketching on this face. Let's go with convert entities, and I want to select chain. Oh, I think actually loop. It only gives me the option to select chain, so I'll just say Control A. Alright, I'm starting over, and I'm saying select tangency, convert entities, Control A. I guess I have to get back into the sketch. Now I can select tangency, convert entities, Control A, offset entities. Well, first off, I'm going to Control A for construction. Okay, with these entities converted, I'm just going to use this to rebuild features. So swept cut from here along here, both sides. And there we have a groove for our gasket. So we should be able to, at least theoretically, have a pretty decent valve cover. I might want to move this more towards the inside. I feel a little bit better about the sealing quality, so let's do that. Let's go with 0.2 be too far, that would. 0.15 and rebuild. There we've got a little bit more of a thick lip. So that looks beautiful. Again, Control 7 and save. Okay, I want to address one of the things that we've cut some holes in our material reduction cutout. And so let's address that. I think we've got a pretty simple way of doing so. If I select this face and sketch, SolidWorks will let me Control 8 to this face. There we go. While sketching on this face, I can choose here, convert entities, and choose this, and I can make a very arbitrary, something like 0.1, and now I can Features, extrude, through all. Except I want to reverse direction. And of course, get that little nudge there. So since I want this to be smooth, we'll say up to surface here. That's better. And now I can linear pattern in this direction. And I'm not sure if that's the right extrusion or not. It is. What you see is we've added this protective wall around that. And so we are going to be much better off and more protected. The other thing is I most certainly can do the same thing, just, offset a sketch off of this slot and extrude up so that I can have the exact same thing for my coolant. In this case, I think it would be better form to quickly adjust the dimensions of my slot slightly. So I'll edit my sketch here. And you can kind of see where the problem is. And so I'll take this from 60 degrees, let's go 50. Of course, you probably want to verify that your flow parameters are still going to work well. And it takes a long time to rebuild when we change something early on. But as you can see, we've got no rebuild errors, particularly because of the way that we've constrained, and our coolant jackets have automatically updated to the correct dimension after we've made that adjustment. So that's the beauty of design intent. In fact, I kind of did this so that you could see how good design intent works. But we still have, oh, it's because I didn't mirror that extrusion, but over here we are perfectly good. We're in great shape. So let's mirror across the right plane, and we'll mirror our last extrusion. And its pattern. And now we've got, again, that protective layer so that we don't have to worry about our bolts being exposed near the bottom. It'll be a constant tube. Alright, let's take a look at what adding that wall did to our coolant channels, if anything. So it looks like we have just a minor obstruction here. Again, I don't think that's that big of a deal to have a minor flow obstruction and have a really good wall thickness there. I think that looks okay. Come on, SolidWorks. You can tell this is getting a little bit system heavy with all the resources that I'm using, but what can I say? I just love real view so much, I'm going to leave it the way it is for now. Okay, I want to address my spark plug tubes. As you can probably tell, we're going to have a spark plug going down into this face, and when I do, there's going to be oil all over this place, and you don't want oil to go in and short out the plug. So let's work on something that will protect our spark plug. The first thing I want to do is select this face and get normal to it. Maybe I will get rid of real view for a second so that I can move my views a lot faster. I want to sketch on this face, and Relative to the center, I think I want to go with an outer diameter of 0.6 inches, and I want to convert entities here. Let's extrude, and we'll go a distance of 0.7 when we extrude. Now, I've got a plane that goes right through the middle of this. Plane 2, yes, it is. So we'll cut our view on plane 2, and then on plane 2, we'll also sketch. But of course, my view is not on plane 2, so that's why I couldn't see what I was looking for. Plane 2, that's it. Now in my sketch, I can draw 2 rectangles. I hope I didn't get I got a little coincident constraint, so we'll get rid of that. And from here, I can give this an arbitrary depth of 0.24. Again, Parker O-Rings has some amazing resources on how deep your grooves should be for specific O-ring and everything else. I should probably talk to you a little bit more about what the strategy is. So our valve cover will have a tube that will come down, and we can seal with 2 O-rings on this tube, and that will prevent oil will have to come up, go through 2 O-rings, and then back down in order to short out the spark plug. So we'll be really well insulated from the possibility of shorting out. We'll make these vertical, and we'll make these of equal length. Now I can add some more dimensions. We'll go with, say, a height of 0.8, 0.08 rather. Again, arbitrary dimensions. 0.08. Now we'll go with something like a distance, probably just enough to get the face out. 0.07 should work. Now what overall height do I want to put these at? And let's say from the origin, I'll go 1/2 inch. Oh, but that's a little bit too high, obviously. So 1/2 inch minus maybe 80 thou, that looks pretty good. Adding a center line. Let's revolve cut. Not bad. Now I'd like to linear pattern in this direction. Let's go here. That looks good. Of course, you saw those grooves in the preview, but they didn't show up. That's better. Control 7 and save. Now I'd like to perhaps work on some of the cosmetics and maybe a weight reduction. So let's make a plane, and we'll go something like 0.15. We'll go into my cylinder head here. So when I cut my view, I can see that my plane just hits empty space. Like there's no real feature down here that I need to worry too much about. So I've got a bunch of extra material. So let's sketch, Control 8, and on this sketch I want to make a series of rectangles. And let's add some equal relations. Equal. Equal. Collinear. Collinear. And collinear. We'll add collinears. Now I can add some simple relations. Maybe we'll make this 1/8 inch. Same here. And here. I can go 1/4 inch. Maybe from the top I can go another 1/4 inch. And maybe I'll make this a distance of 1 inch here. That'd be pretty good. From the edge here, you know, I think for importance of design, I'm going to quit while I'm right here, and I want to have more rounded edges as I work around this sketch. So I think as important for design at this point, I can justifiably, ostensibly add a fillet around here. I want to go with 0.35. I'm not sure what's happening there. We'll see how that turns out. Looks like I'm too large because of that feature, so let's dial it down back to 1/4 inch. That'll work. Let's roll forward to the sketch. Maybe from here I'll go another 1/4 inch. Collinear. Collinear. And collinear. I'll do another 1/4 inch over here. And then maybe lengthwise I can go something like 1/2 inch and 1 inch. Nah. I'll make these equal. And so these will be some strength adding ribs. So I'll say features, extruded cut, up to surface. Choose the plane that I've made. And there's a lot less material now, and I am able to fillet this to look a little bit more realistically cast. Of course, I don't want that. I want this face. And instead of a 1/4 inch, we should give it a fillet of something like 0.1. And then I can add the same size fillet on the other side. I guess I'll have to go with a shorter fillet, smaller radius. All right, 50th thou it is. I think I'll do one more set. Quarter inch should work. There we go. So we took some material out and we have some strengthening ribs that are going through here. I'd also like to add in a little bit for the camshaft here. I'll sketch on this face. That did not go the way that I wanted it to. See if a concentric relation will fix it up. I think I've got some kind of relation that I don't want. I'll have to start over there. Make these equal. Make this concentric. Now hopefully equal. Oh, they're already equal. Quarter inch doesn't look bad. Now I can use a convert entities. centric, and we'll keep a constant thickness of 0.25. I should have the shading of a closed profile, and I don't see it. That did it. Maybe I'll go 1/8 inch. We'll probably need a coolant temperature sensor. So I'm going to show my hidden lines and maybe get rolling on a coolant temperature sensor port. I'm going to start with being tangent on both ends. And now I can make myself horizontal, but I think I have to put down a point in the center of my circle. There we go. I can extrude cut up to next. And we've done it. I'll choose this face. And I can give this probably a consistent dimension of 0.1 as we've done on this output flange over here. And I'll keep a consistent distance, so we'll say up to surface here. That's looking pretty good. So there we've got a temperature port that we can use as well, temperature sensor port. I probably want to reduce a little bit of weight on these flanges. So I think what I'll do is sketch on this face. I'll make apparently a very small rectangle. I'll show hidden lines. I'll create a construction line so that I can reference the center between cylinders. Easily. Choose the center point and make it vertical. I'll also want to see if I can find a center point. Doesn't look like I can along here. And there's one. And so we'll take that center point and make it horizontal. And then I can make a dimension of 1 inch. And I can make this as wide as I want to. I would consider maybe 1/8 inch wide. That looks about right. And probably be easier to get back to my normal view now. Features, extruded cut. We'll go offset from surface, and we'll 1/8 inch is fine. So we'll extrude offset from that surface by 1/8 of an inch. Then, from that small weight reduction, I can linear pattern in this direction, one less, Looks like with that error, I'd probably just be better off doing a simple face fillet. Not face fillet rather, but face pattern. I was thinking about filleting my spark plug holes just then, and I'd have to use a face fillet for those. Alright, with that pattern, I'll go with mirror across the right plane. And I can choose my initial cut as well. Well, looks like that's not going to work. So let's see. Oh, but it copied just fine. It just didn't preview that third one. So with that being all patterned, I'll add in a fillet here. And since I've got a stud right there, I'll just add more material in that corner. But I won't select the whole face, just there. And that's hopefully a little strength adding feature, because the fillet will disperse any stresses a lot more efficiently. Okay, that fillet's added. I think it's time to add the fillets that we've been waiting to add for the entire design. So let's get started. Fillet. We can fill it along here, and maybe I wonder what's stopping us from being able to add a fillet on here. Did that go? That went. Alright, well, I think a small 30 thou radius is fine. That'll be a little bit more realistic for casting. There we go. I think I'll do the same over here. Let's get started down here. Alright, adding fillets is probably the most entertaining part of this entire video. I can only imagine your excitement as you're going through and doing this with me. Adding a few more. I already had a few there. It's late, I've been at this for hours, I'm losing my voice and I'm quite tired, so I'm just going to pretend like I didn't see those fillets were there. Alright, let's jump on the inside. Outrageous. Yeah, we'll need to face fillet this one. No, looks like I can only do one at a time though. Yep. Nope. So you could probably knock all those out pretty easily. And that will be for much better flow. Yep. We've got a good fillet all the way around those. So let's call it right there. This is our cylinder head. Now there's a few improvements that you might want to make. You might want to make some, bracketry or gasketry on the front, maybe some more sensor places. I'll put this in real view so we can get a good look at it. You may want to, do something about this gap in here, but this is a good general cylinder head. I hope this was helpful. In fact, you know what? I'm going to do one last thing, and that would be to sketch on this face. I'm going to add just a little more detail and definition here. That's better. Uh-huh. Not bad. A mirror. Center. We'll cut that to a depth of 50 thou. Excellent. And we'll give that a fillet all the way around of 50 thou. Excellent. All right, let's do some finishing touches. I want to go way back to some of the early planes that I've made, and I think it's plane 4 that calls out our valve angle. Let me get normal to plane 4 and sketch. Now, as we talked about in the very beginning, we need to make some room for a valve seat. So let's start with that. In fact, I think it'd be easier to have design intent by doing only one of these right now. And let's go make a diameter something like 1.01, and I'm going to extrude cut And let's go through all. And then on this side, direction 2, we'll say something like blind down to 50 thou. And now I've got a spot for the valve seat to go. Now, it's important to see that we have a degree of being concentric here. We wanted those straight lines from the beginning that guaranteed at least 0.2 inches for these valve seats, because if this started curving the minute that I started extruding, we would not have a concentric relation here, and we would really struggle to have a good valve seat. So that's what made that possible. I would like to linear pattern, and I can just choose an edge in the direction that I want to go. We'll choose this feature, and we'll do a distance of 1.2. There we have our next valve seat. I can mirror across the right plane. There's a valve seat. And now I can linear pattern again in, well, not that direction really. Let's choose an edge where I want to go. Let's space it at 3.5. So now I have the cutouts for the valve seat that I would like to have, and I can add some bracket holes for camshaft. So I can add some bolt holes here. I'm going to sketch on this face. Let's say that we need 2 bolts to bolt this down, and yep, we're dealing on the same face here. So let me get normal, and I can choose, say, the very middle of this bracket to make horizontal. I want to choose the middle of this face, and I can avoid using dimensions by making these center lines equal. But I keep selecting these midpoints. There we go. Equal. Now I have to give it a diameter. Eighth inch is kind of small. Perhaps I can do 2 bolts, but since this is just a quick video, 1 should be okay. Real life, you'd probably do 2. I'll make it larger. I can ensure the same spacing by setting this equal and giving this an equal diameter. From here, extrude cut, and let's say we want to go down 2 inches is rather deep. We'll probably run into something, so let's go down 1 inch. That looks pretty good. Now I'll do a linear pattern of what I've just done in this direction, and 1 more. Fills in very nicely for me. Mirror across the right plane. There we have some bolt holes, and those bolt heads will come awfully close to that valve cover, so I'll have to be careful when we design the valve cover to account for that. Okay, so that should be a cylinder head. I hope this video was helpful. To be honest with you, this design, coming up with it from scratch and modeling this to completion to where everything fits together and doesn't run into other things, and then remaking it for this video, and it was a lot of work. This probably took me about 3 weeks in my spare time. So hope this video was helpful. Please subscribe, best way to help me back. I'll catch you in the next video.